Hi, today I'm going to be going over an 820-2530 motherboard, which is kind of a bit of an old piece of shit, and the problem that we're having with the laptop is that when you plug in the charger, whenever I find the charger, I get no green light on the charger, and this is a very common problem. The first thing I'm going to be doing is trying to figure out what's wrong with the one-wire circuit, because the one-wire circuit is what allows the charger to talk to the SMC, and that's what turns the charger on. So let me just go over that a little bit, because it's something that gets asked all the time, and people for some reason just refuse to look at the older videos that I've done where I've explained how the one-wire circuit works. So I'm going to open up the schematic here, and then we're going to go over how the one-wire circuit works so that you can get an idea of what's going on. So over here, we're going to see that this here is where the charger comes into the computer. So it says over here, MagSafe DC Power Jack. MagSafe DC Power Jack. This is where your charger, aka this thing, plugs into the computer in the DC inboard. Now, this plugs in and it has a few paths. The first is PP18V5 DC in fuse. So this is where the 18.5 volts, meaning the actual charger power, is going to go through the machine. The second part that we have here is ground. Ground is needed for you to have any type of electrical circuit complete, so we have ground. And the third path that this takes is something called adapter sense. Adapter sense is where this is going to talk to the computer. So over here you have adapter sense, you have a 0 ohm resistor, and that's going to go over to this chip. Now this chip says ext and int. What do you think ext and int mean? Ext is external, meaning outside the computer, meaning the charger. So this is the pin where this chip is going to talk to something that's outside the computer, external. Then you have internal, int, which is where this is going to talk to something inside the computer. Now over here you have something called sys one wire, and it says bi. Bi stands for bidirectional, and this little resistor over here is something called a pull-up resistor. At this point, I would strongly suggest that you go over my older videos where I talk about what a data line is and how a pull-up resistor creates a data line. That's going to be in the basic, Guide to Basic Electronics playlist. Now, when I search the schematic for sys one wire, I'm going to see that this is a line that goes to this chip called U4900. What's U4900? At the bottom of the page here, it says that that's the SMC, the System Management Controller. So this is what manages the system and allows a lot of things in the system to work. So pretty much the way this works is the one-wire circuit allows the charger, external, to talk to the SMC, internal. But what's going to allow that to happen? Well, first, this chip over here has to turn on, right? This chip has to turn on so that there can be a data line where this external can talk to this internal. So this chip over here pretty much allows the charger to talk to the SMC. Now, this chip has to turn on. So see the VCC pin over here? That VCC pin is where the chip is going to get power to actually turn on and work. So over here you have U6901, which is a logic gate. The way this works is PP3V42 is a 3.42 volt power rail that comes into this logic gate. Now that power rail is not going to get shot out of pin 4, which is the output of that logic gate, unless the input requirements are present. Here the input requirements are that SMC, BC, ACOK, which is about 3 volts, be present on pins 1, 2, and 2. Now if you have power on pins 1 and pin 2, then you will have PP3V42 go through here, 3.42 volts will go to the circuit, and the SMC will be allowed to talk to the charger, and this data line will be created via the pull-up resistor. So the data line will be created by the 3.42 volts over here, and then that data line will talk to the chip will then talk to the charger will then talk to the chip will talk to the SMC via the data line, and everything's good. But you need the 3.42 volts, which means you need SMC, BC, ACOK. Where does SMC, BC, ACOK come from? SMC, BC, ACOK is going to come from charger ACOK. See this? Charger ACOK. SMC, BC, ACOK equals charger AC, ACOK. That's pretty much what this is saying. This signal over here equals that signal over there. Let's search for charger ACOK. Charger ACOK is coming from U7000. U7000 on this machine is a chip that allows the charger. See PP18V5 G3 hot charger over here? That is going to get turned through this buck converter down here, and if you don't know what a buck converter is, I would highly suggest that you look up in my basic electronics video series what a buck converter is. That turns the 18 volts from the charger into, over here, PP bus G3 hot, which says goes to system. Now what is PP bus G3 hot? Well, if we do this, and we look in the beginning of the machine, PP bus G3 hot is a power rail. So see this, PP bus G3 hot is going to come out here. See, follow the line. So it goes zing, 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 PP-3 That's going to go to all these different chips in the machine to power them, to turn on. It's responsible for creating 5 volts. It's responsible for creating 3 volts. It's responsible for a lot of different things in the computer. And that's supposed to be, over here, 12.6 volts. So what's going to happen here is something like this. So we're going to go back to that U7000 page. I love this PDF reader. It's so fast. This is called Sumatra PDF, by the way. If you want a PDF reader that works a lot better than the Adobe garbage, this is called Sumatra PDF. It's amazing. It's legally free. It's very simple. It's very quick. I love it. Anyway, so U7000, which is the chip that controls having the charger turn its 18 volts into 12 volts, shoots out charger ACOK. So this has to be present. Now, charger ACOK over here is not going to be present if anything is wrong over here. So let's say these, let's say the current sensing resistors, and if you don't know what current sensing is, you should look up my videos on what current sensing is. Let's say the current sensing resistor says there's too much current coming through here. We're not going to let out charger ACOK. There's a short to ground over here. We're not going to let out charger ACOK. This chip is on fire. We're not going to let out charger ACOK. AC in is not here. So let's say you don't have the 4 volts that you're supposed to have on the AC in tab. We're not going to let out charger ACOK. So now knowing how this system works, let's troubleshoot and let's apply that process to this board that's not working the way it's supposed to. So first thing I'm going to do is I'm going to plug this in. And let's see if I have 3.42 volts. So PP3V42 is required for this to actually work, right? So let's see if I have PP3V42. So I'm going to put the multimeter on the desk. I'm not sure if you'll be able to actually see what the voltage is on this thing. The way I have it tilted. No, you're not. That's too much light. So there you go. You may be able to see that. I'm not sure if after YouTube's sodomy and compression that you're going to see anything. Hopefully you do. I actually record these videos in lossless, not lossless, so QP equals 1, X264 in high profile. I wind up using Sony Vegas to get it out as a raw AVI file with wave, and then I use FFmpeg X264 at profile very slow to encode it to the exact 20 gigabytes that YouTube will allow, so that when I upload this to YouTube, at the very least, I know they're raping it, but they're raping something that's as close to the original as possible. So I really do hope that you can actually see that. So let's see. So we measure for 3.42 volts, and what do we get? 3.42 volts. So here's what I measured. Let me just show you on the schematic what it is that I measured. U6901. Hey, nice try. Don't switch back. I like having a dedicated open broadcaster monitor. It makes this a lot easier. So what I measured is that right over here in this logic gate, I have PP3V42 coming in. Now what I want to see is, do I have PP3V42 on pins 1 and 2? So let me just open up a board view. So I'm going to close this, and I'm going to open up a board view for this older model motherboard, the 820-2530. And let's get this open. All right, so I need pins 1 and 2, which are SMC, BC, ACOK. See over here where it says the part number, the pin that I'm looking at, and the signal. So see, I can click around and it's going to change. So I want to see if SMC, BC, ACOK is coming through. So let's check that pin using my multimeter. I have 3.2 volts, which is close enough. Also, by the way, if you're interested in knowing how is it that I'm able to measure that, how is it that I can measure that with my multimeter probes, you probably don't have multimeter probes that are fine. If you don't have fine tip multimeter probes, you're going to wind up really, really screwing yourself, because you're going to wind up shorting a lot of things, because these pads are really close together. So if you're using the multimeter tip that looks like this, let's just see if I can get you under the microscope. You're like, this is not going to work. This is huge, even if you take away the residual solder that I've gotten on it. What you want is something like this. See this? Much smaller tip. It's a lot easier to work with. The difference is much more dramatic in person. So let me see if I can just show you really quickly. I know this is off topic to the video, where it is you can get those tips. So let's find that. Here it is. So what I have is this. So I have the Fluke TP88 test lead. So let me just open that over here. All right. So this is it. And again, you can buy these tips for really, really cheap. It's $18.95 with Amazon Prime. Amazon Prime means that you can get this thing in a matter of days. It's a pretty good deal, and you really need these if you're going to work in this business. You need to have multimeter leads that actually allow you to probe things without shorting everything out. So I have 3.42 volts that I'm looking for over there. Now let's see if I can check the rest of the circuit to see what's going on. So I know that I have PP3V42 on the chip. I know that I have the input. I know that I have the input voltages here. So let's see if that chip is actually shooting out of pin 4 what I need. So out of pin 4, I should be seeing the 3.42 volts come through on output. Let's see if I have that. .3. So that's coming through the way it's supposed to. Now let's take a look at U6900. Let's see what's coming through at U6900. So I'm going to turn the board around. Now let's see if the input of U6900 over here has what it's supposed to. Let's see. So here is U6900 on the schematic. So the 3.42 volts is coming out of here. Now, and I know that, so this part of the circuit works. So the U7000 is letting 3 volts go to here. 3.42 volts is present on the power line of the logic gate. The logic gate is taking that 3.42 volts and shooting it out. Now, is that 3.42 volts making it to U6900? So U6900 pin 1. U6900, and let's see what I have on pin 1. All right, so we have that's pin 1. So now let's try to find pin 1 and measure what I have on pin 1. Is that making it to pin 1? And it is. This is where this is going to kind of start to become some BS. Now, luckily, we have a little bit of a visual hint that's going to make this a lot easier for me. So let's just go to the microscope, unplug this for a second, so that I can show you the visual cue that I just found that's going to make solving this problem a lot easier. I just unplug the DC-in board. And let's get this situated in the microscope so that the problem is viewable. So that's the chip on the, there we go. So that's the chip on the board view, and now I'll take a look at it in real life. And what do you guys see? Anything stick out to you as wrong? Anything stick out to you as wrong? Well, we have a corroded pathway here. Yuck, liquid damage. Poo, pah, pah. So from here, that goes to this probe point, and that probe point is then supposed to go over here. But what you'll notice is that right over here, this is all corroded away, and when you zoom in a lot, by the way, thank you for to iFixit for sending this microscope, because it has zoom that my other one could not dream of. So that's pretty cool. Again, I'm not like a paid endorser of anything, but if you send me shit for free and I use it and it makes my YouTube videos better, I will say thank you. So let's see. So this over here, see where this is broken? Now, that goes to this resistor, and that goes to this pin of U6900. So let's take a look on the schematic and see what that does. So from U6900, pin 5 to pin 2 of R6928. So, let's see. Did I get the pins right, or did I forget? Let's take a look on here again, because I think I forgot the pins. So what's corroded is between here and here. Okay, let's go back on here and see. So between there and there. So adapter sends R. So R6928. So let's check R6928. Okay, so R6928 is this. So pin 2 of R6928, the pathway between that and pin 5 of U6900 is bad. I don't know why my shortcuts keep doing that. I'll figure that out later. Let's just try this again. So my pathway between R6928 pin 2 and pin 5 of U6900 is bad. So the pathway for adapter sense, which is the part where the adapter is actually going to be allowed to talk to the computer, the pathway between the adapter and U6900 on the X pin is broken. Now let's also measure that resistor. So it says that that resistor is supposed to be 0 ohms, and that's something that I feel like can be suspect based on how bad that chip looks. So I'm going to put the multimeter into impedance mode, and let's measure that resistor and see what we get. So when I measure both sides of that resistor, I get 0 ohms. So what I'm thinking right now is if that resistor is 0 ohms over here, so if this is 0 ohms, and the only problem that I really notice is the pathway between the charger and the U6900, which allows the charger to talk to the SMC, is bad. What if I were to reattach that with a wire? So I'm going to run a jumper wire between here and here, and let's see how that looks. Now, I like to use that magnet wire that I talked about in another video for long jumpers because it's insulated all the entire way through. Being insulated the entire way through means I can run a jumper from here to here on the board, and I'm good. I don't have to worry about insulating it. This magnet wire is from CNC Tech. That's CNC Tech magnet wire MW35-C and then space HY. So MW35-C from CNC Tech. However, this wire is a little thick for the purpose that I have in mind. I want a thinner strand, and I also don't want to really deal with insulation because look at the distance that I have to go over here. It's a really small distance. I don't really care about insulation. Look at it. I go like when you zoom out. Yeah, we're still in the microscope here, but when you zoom out, even all the way zoomed out, it's not really a lot of distance. And when so it's not a long way to go. So what I'm going to do here is I'm going to use the wire that I cut out of a MacBook battery. So this is wire that came from a 2011 dead MacBook Pro battery. So if you've ever replaced a MacBook Pro battery for a customer and you throw them away, I would highly suggest that you stop throwing them away because their wires and their strands are perfect for this application. Another cool part about this wire is that you actually have some strands that are thicker than others. So some of these are thick strands of wire, and some of them are very thin strands of wire. It's a very good wire to use, and this wire is 100% free, and it's sitting right in front of you. So to not use it is kind of silly. Now this over here is called the Excelite 175M Fine Tipped Snippers. Excelite, Xcelite 175M, and I use it for stripping these wires and cutting these small things. It's very, very useful. I actually originally bought these to do surface mount rework. I'm not kidding. I was once so broke that when it came time to replace an 8-legged package, I didn't have a hot air station. So what I did is I would snip the legs off of the package using this. I would just make a pretty much wick it off and use a regular crappy $50 soldering iron to get it off, and then I would solder the new one on leg by leg. So I actually bought this so that I could do surface mount rework before I had a hot air station. I'm not kidding. That's people don't start out rich. You don't start out with everything. So what I'm going to do here is I'm going to turn on my soldering iron. This is a HAKKO FX951. The handpiece here is a 2027 with my favorite tip, the curvy tip, which is the T15-JO2 tip. I'm going to turn on the air filter. The HAKKO FA430. By the way, some of you people may notice that I'm giving model numbers of everything. I get asked for model numbers so often that I figure if I say them at the moment I touch a tool, that I won't have to answer a question later. We'll see if that winds up working out that way. But yeah, anyway, so this is the HAKKO FX951 station with the HAKKO FM-2027 iron with the T15-JO2 tip, J02. Now, this is my affected region. So what I'm going to do is I'm going to put some flux here to help the solder flow. This is Amtech 559 flux. It's Amtech 559-V2-TF. So that's NC-559-V2-TF. You can buy it direct from Amtech. Do not buy this stuff on eBay. Do not buy this stuff on Amazon because you will get rebranded Vaseline. It's garbage. Amtech is a company that will actually sell to you. I know it's hard to tell. They don't have add to cart buttons on their website. They're old school like that, but their products actually work. And since their products actually work, it's worth dealing with calling and making a phone order to get this stuff. It will change your life. So I put a little bit of solder over there. I might as well clean up this region with solder and flux, get everything looking nice again. Right. I don't like corroded looking stuff. That resistor didn't look really nice. You know what? I don't like that resistor. That resistor can go. I like things that look nice on the board. Things that don't look nice shouldn't be on the board. So we get rid of that resistor. Fuck that resistor. Let's tin the pads. Get rid of all that nasty old lead-free solder that also probably has corrosion and junk left over from the spill. Poor little Via and Shrey. Poor little Via. So close to being complete. So let's get a donor board. We're going to steal that little piece. Alright, so 0 ohm resistor. I know that I could find a 0 ohm resistor on another board. If I think as I got to open another schematic and another board view, so it would be easier if I could just find another 2530 so that I could steal it from the exact same spot that I saw it. But the 2530 is such an old piece of crap that I'm pretty sure that I don't have any in these slots. I just walk to the other side of the store to see if I can find that board in any of these slots. Are you... Blah. Maybe you. I have a 2327. Let's see if that 0 ohm resistor is there. I know what some of you are thinking. You really should just have a 0 ohm resistor in your tool bin. It's one of the things I really should get the time to buy. I should stop being such a lazy prick. Oh boy, a 0 ohm resistor. Same spot on the 2327. So we're going to take that little 0 ohm resistor. And give it a new home. It will be loved and cared for. I know. You spend so much time on a dead board, you thought nobody would ever care about you. But I care about you, little resistor. Now I'm going to put you on a board that works. This. Okay. Now we're going to cut up a jumper wire and run it. One thing you should realize is that you should not care about the board being comfortable. You should care about yourself being comfortable. I don't care that the board is comfortable. I really don't. If I need to turn the thing around so that I can see what I need to see or do what I need to do, I will. There's absolutely no reason to solder at the wrong angle or drive yourself nuts because the board is sitting there and the board got comfortable. Fuck that. My comfort is important. The board can eat my ass. It's the one that decided to break just because I got a little bit of water on it anyway. The one important thing here is that the wire be flat with the board. The wire cannot be sticking up from the board. If you do that, that's bullshit. I'm not good at soldering and I'm not great at running jumpers, but one of the basic fucking rules here is that if the wire is going to be secure, it needs to be flat with the board and pushed all the way in next to the resistor. The wire is coming out nice and flat with the board. That's important there. Now I'm going to run it along its original path. Security purposes. Make it a little easier to stick. And this little solder cleaning thing that I have, the iron actually comes out dirtier as a result of going through it because it's so filled with solder. One of those things that I just kind of need to replace. So now I ran the wire in and it's gone to pin 5 over there. Just move it a little to make my OCD feel better. Okay, so it's flat with the board. It's being run nice and flat. Could be a little flatter. Jesus Christ, will you just leave well enough alone? So it's there, and we're good to go. Oh, you really have to have it attached on both sides, don't you? That's OCD. So see, I have it attached here, there, on both sides of the brake, the resistor in there. I'm out of my damn mind. That does not matter worth a shit at all. Nobody will ever care. Nobody will ever see this little 6-year-old board but me, and for some reason I give a crap about these things. Now I blow it into place just so it looks right. Dude, this is I went to a therapist once and they said that I did not have OCD, and I just find that hard to believe sometimes. Why the fuck am I doing this? Really? Leave well enough the fuck alone. Alright. Good. So, my jumper is there. Now, onto the fun. Let's see if this actually works and if I did anything right. There's a good chance that I did nothing right. So, I'm going to take the board. Not this. Your junk from 2008. We're going to take the board. Also notice that I clean up my desk as I go. So we're just using the snippers. I put those back. I put the wires back where they were. I put the screwdriver back where it is. So as I'm working, this is a good habit to get into. And this is a habit that a lot of newbies to repair, having a bench set up, don't do. So while you're moving from one side to the other, or while you're finishing one little section of your project, just clean up your desk a little as you go. Because having a clean desk is going to help you have a clean mind, and it's going to help you feel stress-free. The less stress you feel, the more focused you are. The more focused you are, the more work you do. And the more work you do, the more money you make, and the less you have customers calling going, where's my stuff? Where's my item? Where is my item? Why is my stuff not fixed yet? Blah, 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 blah. And that's always a good thing. So I'm going to take a DC in board. Let's see, where's my DC in board? Here we go. So I had a DC in board attached to the computer. I know I did. And now it's gone. I'm sure it's right next to me or right behind me or somewhere that I'll notice right after I plug this in. Oh well. That's another thing about cleaning. When you clean, you usually can't find things, which is why a lot of people don't clean. So I know that I probably put that DC in board away. But I put it away right here. Duh. Silly. So again, this is why you should clean as you go. And clean properly as you go. So I'm going to plug this in. And as you can see here, I get a nice green light in the charger. You may not be able to see that, so what I'm going to do is I'm going to put it under the microscope so that you can see the green light in all of its glory. You can bet you now you can barely see the damn green light because I have the microscope light on. See that? That's the prettiest little thing you've ever seen. That's a green light. So now we're going to do the second test. Second part of my test to make sure that everything is 100% fully functional on this board is going to be to see that the fan can spin. And the fan spins. Now what I'm really curious is, can it beep with no RAM installed? This is an MCP79 based piece of crap. The Core 2 Duo CPU. So I'd be really surprised if anything else works on this piece of shit. So let's see. So I plugged in a speaker. Now I have no RAM in the machine, which means that it should beep. Do you beep? And you don't beep. Well, it's an old piece of crap. And do you think I'm going to go further into troubleshooting this? Absolutely not. I have no intention of spending my time replacing the Core 2 Duo CPU or an MCP79 on a fucking liquid damage board from 2009. But I did get the one-wire circuit to work, and that was the point of this video. I really was expecting this to be a complete pile of shit that didn't work, and that is exactly what it turned out to be. So ultimately, that's it for today, and I hope you learned something.